everybody. Today I'd like to talk to you about if you really need Hibernate or if there are some alternatives. To start, maybe a short introduction about me. I'm doing software development for close to 30 years now. I started on IBM mainframe in 1995 and then moved to Java. I'm a consultant in Switzerland working for small companies to even large companies. I'm also active in the Java user community and I'm teaching at the university. So persistence and Java is a topic that I already have for many years because I'm also teaching JPA and Hibernate at university since 2007. Now, before I will talk about technical stuff, let's talk about something completely different. Let's talk about track and field. In Switzerland, I'm in a sports club for many years, already since I'm a kid. And we have a few competitions every year for kids. So they can come and do long jump or sprint and stuff like that. And in the early days, we did the calculation of the results by hand. So there are tables, you can find the result, maybe 2 meters for the long jump, and then you will find points. You have to write that down and calculate the points. And around 1997, I thought, no, that's not a good idea. So we should do that with kind of software, because then I was like 2 years working as professional software developer. And so I created a program that's name is currently Track and Field, and is open source. So you can find the application online. It's also on GitHub. So if you have track and field competitions, you can use that to calculate the points. Now I'm talking about that. Maybe let's have a look how this application looks like. So this is the dashboard. Here you can see that we have all the competitions from this year. So the next one will be on August the 26th. And before we had one on April the 29th and May 13. And there are various stuff that you can do with the application. The most important part for sure is I can go ahead and, for example, check out the results, enter the results, and the points will be calculated. So here we have like a formula that's from the International Track and Field Association that I just adjusted because the regular formulas are for adults and not for kids. And we have very small kids, so we have like kids 4 or 5 years old, and they don't do a lot of, or a long jump, for example, or not so fast, so I had to adjust the formulas. Now that's one thing that I have to do. Currently this is done manually, so they fill out a paper and then I will enter results. The idea is to have that mobile first in the end and to have a mobile application for the judges to enter the results. But finally, the other important thing is I want to create a ranking list, so I can create this ranking list here. So that's more or less the tree with the competition. We have categories based on the age of the kids, and then we have the participants, and here below you can see the results. So for example, Franek here did 11:25 in 80-meter sprints. So that's the business case of my application. Now why I'm talking about that? I'm talking about that because this application is very similar to a lot of applications I'm usually doing for my customers. And what this means, so if we go to the administration side of the application, I have to do a lot of CRUD. So I have, for example, here the series, so we can have 2 competitions in one series, so we will have a series ranking list at the end where only participants will be on the ranking list if they participated in both events. And here we have classical create, read, update, and delete. So that means in my application, I have very few points where I really need trees or nested structures. So usually I have single records, right? So for example, here we have the competition with the name and the date. I can edit that. Here's the same name and date. I can change it, save it to the database, and that's it. Now the point was, how do I do the persistence part for that kind of application? And in a recent project, I was dealing with a large Oracle database. It was an ERP migration project, and there we had around 2,000 database tables and 4,000 stored procedures, and the question was, how do we access this huge database? And then I come to a project that's called jOOQ, jOOQ, and that's what the alternative is that I like to talk to you about today. But before we dive into the code, let's see how the data model looks like in my application, because I will show you then a demo based on this data model. So on top, we have the organization. That means there can be a club, for example, or someone else who wants to organize such a track and field event. And on the organization, he will usually add athletes. Athletes may or may not be in a club. And then you can create a competition series and add competitions. Very often there is only a single competition in the series. And you have the categories based on the age usually. And then the events here on the lower right side, these are the various types of sports you can do. So 80-meter long jump, high jump, whatever you want to do there. And finally, we have results. So every athlete will get a result in his category on a competition. And finally, we could also do some calculation based on the athlete if he has proceed or he will get better during the years he do the competitions. Now the question is, before I show you what jOOQ even is, maybe some ideas about differences if you want to deal with databases. So I'm just speaking about SQL database. I will not talk about NoSQL database at that point. But often it's not the technology that is the point that distinguish the two solutions, but there may be two different approaches. So if we take a look at JPA and Hibernate, there is usually an entity state transition. So the goal of using JPA is you load data, this will be transformed in usually an object graph. Then you change something at the object graph and you don't care, you just save that. And this works very well if you have exactly that approach. But the problem there might be that JPA and Hibernate the problem is that there's the impedance mismatch between object orientation and relational databases. So maybe this will be not the best solutions. On the other hand, we have what I've shown you before. It's called dataset transformation. So that means I read a dataset, change it, and save it back. So that's classically select, update, insert, delete, right? And the point is, there is no best solution. So I don't want to talk to you that you should use jOOQ from now on. The point is, I will also show that there are combinations to integrate JPA with jOOQ, for example, and depending on what you want to do with the framework. Now jOOQ is around 50 years old. It was created by Lukas Eder. He's also from Switzerland. And he had a problem because he was working for a bank in Switzerland, and they had to access also a large database. And the question was, how would they do that? They thought that maybe with Hibernate this will be not what they really want to do, and so they created jOOQ. So that was the beginning. In the meanwhile, jOOQ more or less supports every SQL database that is there. Even other databases that are not only SQL databases are supported. And this also means if you use jOOQ, you're independent of the database. So that's the similarity with JPA. So if you use JPA, you don't have to care if you're using Postgres or MySQL, for example. This will work in both cases, and Hibernate and also jOOQ will transform the queries in a SQL query that will be understood by the database. So that's the idea. There's a side effect about creating jOOQ from Lukas. He's probably the only person in the world that knows every SQL database. So he filled many issues, for example, with various databases that he found out during developing jOOQ. Yeah, there's a question. Yeah, the problem is then it will not be on the recording, so we cannot get rid of that. I know it's terrible. It's also terrible for me. I try to close my eyes, but that's quite. Uh, hmm? I don't know if this works. So that's already the yesterday the same issue. Yeah, sorry about that. Now, how do you start? First, I created an example project. We will have a look at that. It's available on GitHub. Then there's jOOQ with an official documentation, and there is also a demo. But I will not use that demo data model because usually jOOQ, if you see demos, they are using the Sakila database. That's the old MySQL demo schema for a video renting store. I will use the project that I've shown you just before. Now, if you're using jOOQ, you move away from the idea that you first create a class model. So what you do with jOOQ, it's always database first. So you need to create a database with SQL scripts, for example. Usually use Flyway or Lickybase to do the migrations. But the point is, it doesn't matter how your database looks like. So in contrast to JPA, where you have to follow some rules that the mapping would work, or you have to do a lot of mapping, jOOQ isn't biased here to have something, so it can more or less generate classes from every database type. Now, how does this work? jOOQ has two parts. First of all, you have the jOOQ generator. So the jOOQ generator takes the database schema and generates Java classes. We will see what kind of Java classes will be generated. And then you have the jOOQ domain-specific language to write SQL. So the jOOQ domain-specific language is more or less SQL, but in a type-safe form, because usually you use strings. So this is a bit better now, since we have text blocks in Java, but it's still not safe. So if you change a field, for example, in the database or column in the database, then probably your code will no longer run because you still have the old name anywhere in your code in a string. So now we'll go to the code, and first we go to the example project. The first thing that we want to do is we want to generate the classes from the database. And for that, there is a jOOQ plugin. So by the way, this is a simple Spring Boot application. There is also Spring Boot Starter for jOOQ. And here down in the build section, we will find the plugin from jOOQ. And the jOOQ plugin has some configuration. First of all, we can define where the data model is. In the simple example, I use H2 and Flyway, and therefore I can use a DDL database. That means jOOQ will generate the classes necessary to do the SQL statements from the DDL scripts. That's a funny idea if you do presentations like me, but it's not really what you want to do in a real-world project, because the DDL statements can vary depending on the database. You can have stuff in the DDL statements that may not be understood by jOOQ, so it's much better to have a database running and generate the data model or the classes based on this running database. Now you may argue, yeah, but then I have to have a database running anywhere, but I will show you that there is a solution that will work very well without having a database installed anywhere. So that means because I'm using the DDL database here, I have to tell where the SQL scripts are. There's a property because jOOQ needs to know how to sort the SQL scripts. And then in my case, I just have a package name where I want to have the generated code in. There are other configurations that you can do. You can not only generate the classes necessary to interact with the database, you can also generate like repository layer directly that you can use where all find methods will be, but that's another topic I don't talk today about. So if I run that, or we can run it, then you can see what happens. So for example, I do compile here. Then you see that the generator runs, and here we see some information. By the way, the Java generator parameters, you can see what you can generate. You can even generate bean validation stuff. So based on the not null constraints, for example, on the columns, jOOQ can generate bean validation annotations, or we have different stuff here like POJOs or the DAO layers, so the data access objects that could be generated but are not generated currently. And here we see that jOOQ will introspect the database, and then it will start to generate classes for each table, and that's what we are going to have a look at. In the target directory in generated sources, that's the default location, you find the jOOQ package, and there we have our generated database. So there are some information about the database. So for example, we have information about the catalog or the schema, but that's something that jOOQ will use then to produce the SQL statements. We don't care about that. What's interesting for us is everything that's in the tables folder. And here you can see that for each table, so we have athlete, category, and so on. These are our tables that we have in the database. There are others like category athlete or category event. These are the tables because we have some end-to-end relationships. So there is usually a relationship table involved, and also for that table we will have a table generated. So let's have a look at, for example, the athlete class that is generated. And here we can see that we have first of all, some constants. So that means we have a constant athlete, and that's the constant that we will use to create our SQL statements. We will see that in a minute. And then for every database column, we will also have one of these, and they are typed. So that means jOOQ generates an ID that is of type long, the first name of type string. And that's not the only information. We also have additional information. So example, what is the SQL data type, how long is the field, what is the nullability, and so on. We will also see later in the class that there are some information about the primary key. So we can get the primary key. That you usually don't need, but in the ERP system I was talking to you before, I generate the UI based on the database model. And this is very handy because I get all the information from the database about the structure, about the typing, to generate some dynamic UI. So that's very helpful, because otherwise I could do that as well. I could use the results at metadata to do that. But with jOOQ it's much more easy, it's much easier to achieve such things. Now that we have the classes, we also have records. So again, for each table, we will get the record class. And the record class is more or less the result from a select on the table. So the record will have all attributes. So we have the ID, we have first name, last name, and so on, that we can use if we select data from the database. And there is something special. If the table has a unique or a primary key, then it will be an updatable record. Updatable record means we have something like an active record where we can change the record and call store on the record to save the data, so we don't have to write update statements. That's the idea of that. So that's what jOOQ generates. As I said, you can also generate POJOs if you don't want to have these records, or you can generate data access objects to interact with the database. But I will show you how you can use jOOQ directly with the DSL. And here we see our jOOQ test. And jOOQ test is an annotation from Spring Boot. So that means Spring Boot test will only start what's necessary to run jOOQ test. Like if you use JPA test for those who use Spring Boot, it's similar. So it will only start more or less the database connection or the connection pool plus the DSL. And the DSL class that we will use is DSL context. And this is also generated and configured by Spring Boot in that case, and you can use that right away. So let's have a look at how we can find some data. So I want to find all competitions. And here we have a shortcut, because usually this would be select something from competition. But if we anyway want to fetch all the columns of the competition table, then we can have select from, and fetch will then execute the query, and the result is an extension from list. So we will get a list of competition records, and the competition record is the type that was generated also by jOOQ. So that's pretty easy, I would say. The point here is it's type safe. So first of all, what does type safety mean in terms of jOOQ? The first thing is, because of the DSL, I cannot write wrong SQL statements. So I have a Fluent API, and I can only use what's there. So I cannot mix from and select or where and stuff like that, as I could do if I would write a SQL statement in a string. And this will also help, because you don't have to test that. So you don't have to test that in terms of, does the SQL statement even executes? You have to test it to see if you get the data back that you expected, but not if the SQL statement works or not. And here we see also the generated constants of jOOQ, and this makes it type safe in terms, if I change the table name here, for example, my code will no longer compile. So that adds additional type safety and also convenience, because I don't have to guess how my columns are named or how my tables are named. So this works quite out of the box with jOOQ. Then let's have a look at an insert statement, and this is something that really looks like SQL again. So I have to specify the columns and the values for that. What I can do here with this returning result is that I have an ID that is generated by a sequence. So the table has a default value for the ID that uses a sequence, and returning result will create and insert the statement with returning something clause. And then I will get the ID and can work with the ID further on. So. But often this is not so handy. So at least insert statements, something must be easier to use. And that's where these updatable records came in. So I can, for example, here create a new athlete. And the reason why I call new record here on the DSL object is because the athlete record then will be managed. So you know that, or attached in jOOQ, it's named attached, but in JPA it will be managed. So you have the managed state in JPA, for example, and here it's the same. So jOOQ knows about that record and will also be able to store that. And then I can set first name, last name, and so on. And finally, I will store the athlete. What you also see here is with jOOQ, you don't have any relationships. So jOOQ will generate exactly a class model based on the database model. That means club ID and organization ID here are both foreign keys to the club table and the organization table, and I will set just the ID. Now we can argue that's not practical, because you want to set like instance of the club class, but the question here is, do you really need that, or do you really have that? So if we have a look at our application, for example, and we have the athlete, then we see here we have the club down here. But in fact, what I'm displaying here is just a list of clubs, so we don't have that many. And the binder of the field in the UI just uses the ID, so we really don't need an object here to set on the record. So that's the reason why this works quite well, and you even don't need that. And here you see what I talked before about active record. I can just call store, and store will execute either an update or an insert statement, depending on if it's a new or an old or an existing object. The point is that jOOQ there adds some additional functionality as well. So for example, you know the version field that you can add to an entity in Hibernate. jOOQ can do similar stuff, so you can define optimistic locking. That also works on a timestamp or on an ID or a version field, for example. You could even make that work with all the fields, so you don't need anything special. jOOQ will create a where condition with all the fields for the update statement, and so you will have optimistic locking even if you don't have a version or a timestamp field on the database. Now that's it if you like to work with these records, but what if you want to do some projection? So for example, I have here a class that, let's see, an athlete DTO. So I want to get just the first name, the last name, and the club name. And this is a Java record, which is very handy because it's an immutable data structure, and usually for projection you want to have immutability. And then you can directly use that in jOOQ. So I create here a select statement with a projection. I use the first name, last name, and the club name. And I do a join here on the club table. And finally, I can use the fetch into method that then directly will create an athlete DTO for me. So how this works, jOOQ will try to create this athlete DTO based on the constructor. So if the constructor parameters matches the result of the SQL statement, then this will work. jOOQ has some fallback. It will try to call setters if this not works. If there is a standard constructor, that we will not have because records has no standard constructor. We just have that one with the parameters. And if this doesn't work, if you have some special classes, you could do the mapping yourself. So it's also possible to call map instead of fetch into, and then you can do whatever you want. You will get a lambda where you get every record in, and you can do with the record whatever you like to. Now the point is this join clause here. So from a Hibernate perspective, this is not necessary, right? So if you do a JPQL query, you can navigate by to-one relationships without writing join, and jOOQ can do that as well. Because he knows about the database structure, he knows how the tables are related, you can use a shortcut. That means for every to-one relationship, jOOQ will also create, in that case, a method club, and with that you can directly navigate to the name of the club, and you don't have to join explicitly. So this will generate the join in the SQL statement, but you don't have to write it, and this is very handy if you do projection. And finally, maybe we want to delete that, so we can execute the delete from, for example, and have a where statement. Here you have an execute statement, an execute method, sorry, and that will return the number of deleted rows in that case. You could also use the record directly to delete, but in most cases it doesn't make sense to load data to delete. So that's something that with Hibernate you usually do. So you fetch a lot of entities and then you iterate over the entities and delete them. That's simply unnecessary because you can delete the data anyway. Here it's not a problem because you don't have a session or an entity manager persistence context like you have in JPA. So it doesn't matter if you delete something because you will not have any references to that data anyway in memory. So that looks nice, but something that bothers me most when I'm using Hibernate is lazy loading. Who of you has lazy loading issues? So lazy initialization exception stuff, you want to load nested objects and then you access that. There's some anti-pattern like the open session view that Spring Boot has by default enabled. You will not even notice that, but you get this n+1 bomb and thousands of statements probably. And with jOOQ you don't get that anymore because first of all there's no lazy loading, but we have a superpower that Hibernate doesn't have. Let's have a look again at our ranking list. The ranking list is a tree, right? And the result of a database query is what? A table. So how can I return a tree of data and map it to a structure? If you do that with Hibernate, you can do join fetch or you can use entity graph, but the result will always be a table. So you will get a lot of data duplicated because it will create a product of the joins. jOOQ does that in other way. It creates just one single SQL statement and returns only the data necessary for this tree here. So how can this be done? Let's have a look at my application. And first, before we go into that, I like to show you something else. Because we were talking about the generation of the classes based on the database model, and we've seen that there's a DDL database that we can use that's not very handy. Now, for some time, we have a project called test containers. Who knows about test containers or who uses test containers? Already about half of the people. Test containers is the idea that you start a container on your computer, Docker container, and you can use that to test. So you don't need a running database, but you can use test containers that will start the database when you test, and you can access the database during the tests, and after the test, the database will be shut down and the container will be removed. That's the idea of test containers. You can do that locally, or the company Atomic Jar also has a test containers cloud where you don't even need to install Docker. You just can install their client, and then your container will run in the cloud. And when test containers were new, then I thought, or a lot of people using jOOQ thought that could be a perfect fit. But the problem is, how can I start a test container? Because usually if you do that with Spring Boot, for example, there are extensions from test containers who will do that for you. But how can I do that in a Maven build? And the old idea was I have to start the test container in a way that I can use it then. We did that mostly with the Groovy plugin because there you can do some programming in Maven. If you have Gradle, you can do that without any special tricks. And test containers also saw that issue, and what they did, they created the test containers jOOQ CodeGen Maven plugin. And the cool thing about that is you can use test containers. So I use test containers Postgres here in my example. Have to specify, for example, sure the Postgres driver, and then I can do some configuration. First of all, I have to configure test containers. So here, for example, I say that the type of database that I want to use is Postgres. I can define the container image. So I think 15.2 is one of the newest ones. Then I can use here username and password. I don't have to set that because test containers generate the username and password for me. But in that case, I need that. And then I can also define a database name. This is often not necessary, but if you have SQL scripts that use the database name somewhere in the scripts, you have to specify that. And then you have to specify where the migration scripts are, because this plugins assumes that you either use Flyway or Liquibase for database migrations. So in my case, I say the database migration script and Flyway are in the standard path here in DB migration. I'm not 100% sure, but I think this is no longer necessary because this is the default location anyway in a Spring Boot project. And then I have the jOOQ generator, and everything that goes under the generator here is jOOQ standard. So I can use all the properties that are there in the documentation, and you can add that here. For example, I exclude the Flyway schema history table because I don't want to have classes for that, because I do not access the Flyway generated table. That's not necessary. And here, like we've seen before, I also use like this package name. So everything will be generated here for me just in one plugin. That's very handy and very useful. And so if I run the same here, if I do a compile, then we will see that a Docker container will be started. Here we see that this checking for Docker creates the container, then it applies the flyway schema migrations, and it generates the code. So that's pretty fast. Why it's so fast? Because Postgres is so fast in startup. So Postgres is much faster in startup than many other databases, and so Postgres is perfect fit if you want to do such things. So I like Postgres just because of the startup time. If you want to do that with Oracle or with SQL Server database, you will have to wait a few seconds more than here. Right. So now let's get back to our initial problem, the ranking list. And the query for the ranking list is the last thing I like to show you. It's here in this competition ranking service. And we see a nested SQL statement. So that means in the first select, I select the name, the competition date. Then there are some configuration about the medals and so on that I need. And then I have a multi-set statement. By the way, the SQL standard export group is thinking about adding such a multi-set or nested table structure result set in SQL as well, but this will take probably a few more years until every database may have implemented that. But if you use jOOQ, you really already have that. So I have a multi-set here, and then I do a nested select from the categories. So I use the abbreviation name, then the year from to, that's for the age category. Then I have another nested select for the athlete, and another nested select for the result. And the result that I want to get back finally is a nested record structure. Let's have a look at that one. Where do I have that? That's this one. So here we see that I have exactly the same that we nested before. So I have an outer record and an inner record category, an inner record athlete, and an inner record result. And that's what I want to get back, because based on that tree, I will generate a PDF with some PDF library. And so we have the select here. And the interesting part of the query is not really the select, but how we deal with the result. And for the result, jOOQ provides a converter. And this is when you use the convert from method, you also get every record of the inner select, and you can map that then finally to result. So here, as you can see, it's a static method reference to the constructor. So for each record will the constructor be called, and this happens for every nested structure. And finally, we have fetch one. Fetch one means I assume only to get one result in the result set. And here you can use the mapping to finally map everything that was created inside this structure into the most outer record structure. And that's really a superpower, because this is, in my opinion, the best or one of the best features of jOOQ that you will not find in any other solution. And the question maybe is, how can jOOQ do that? Because as I told you before, the result of a SQL statement is always a table. The trick here is most of the database products today provide XML or JSON functionality, and you can return JSON from a SQL statement. So you don't need to return a table, or you get the table but with a single record, and in the single record is probably only one column, and in the column you will find just the single JSON structure. So that's the trick how jOOQ can do that. By the way, you can use that as well. So jOOQ also provides XML and JSON functionality. And for example, if you're creating a REST API, you don't really need objects maybe. So if you don't want to do with objects anything, you could go ahead and create a JSON query that returns JSON, and you can just return the string if you like to. Okay, now what about jOOQ and JPA? The point is you can easily integrate jOOQ and JPA, because with jOOQ you can create queries, for example, and then pass this to Hibernate native query. So Hibernate has a method, create native query. You can pass the SQL string directly there. By the way, There you will not have any SQL injection problem with jOOQ because jOOQ always creates prepared statements. So there's no way to have SQL injection. But you can get the inline SQL back from jOOQ and pass that to JPA. So you could also get entities as a result from a jOOQ query if you like to. I have projects where we use both. So if we have complex queries or something like the ranking list here, then we use jOOQ for that. And if we want to do changing data, if we have kind of a domain-driven design approach where we don't have an anemic domain model, but a rich entity model with also some methods, some business methods on the entities, we use JPA, and this works quite well. So it doesn't mean that you have to choose between one or the other. jOOQ could also generate the necessary classes based on the entity mapping, by the way, but this often doesn't make sense. So I didn't find a use case for that, but it can do that as well. Now the point is which one to use. As I said, you can combine that, but for me, really the superpower of jOOQ is querying, like the nested structure. And I didn't talk about that, but if you have legacy databases or databases that still use stored procedures, you should also really use jOOQ. Why? Because jOOQ generates for every function and every stored procedure method a class. So you can instantiate the class and execute the class, and then you get the result from the stored procedure. And that's very handy. So it's by far the most easiest way to call functions and stored procedures from Java, because with Hibernate or with plain JDBC, this is a pain. So calling stored procedures and functions is not that easy. Bulk updates and deletes for sure is something that you can do with jOOQ. And if you really have that rich domain model and you need or you want that entity state transition, maybe you also have like domain events that will be produced from the entities and stuff like that, then I would go with JPA. And what also very handy if you use JPA, you have cascading. So if you have like aggregate root in DDD means, then you can just save the aggregate root and everything else will be updated, deleted, inserted, whatever you could do there. Yep, that's it from my side. Are questions? No questions? Okay, thanks a lot for attending my talk. By the way, I will have another one in the afternoon. I will talk about full stack development. If you're interested in that topic, it will be at 2 o'clock. Thank you very much for coming.